Today I want to talk about parameters, but I wanted to try to do it in a way that was a little more meaningful. So what we're going to do this go around is work on creating this object here. What this is a propeller placeholder for a mini quad. It's a plastic object that we could 3D print that we could put onto a motor shaft that won't hurt if it spins, and it'll give us clearances, physical clearances, to let us know what we can or can't use. Now, because this is going to be 3D printed, a lot of the dimensions I'm going to be using are going to be sort of base 0.4 if, in a way. In other words, they're going to be derivatives of the nozzle diameter of 0.4 millimeters that I'm going to be using. So if we look at how I drew this particular object, you can see that I just created a whole bunch of statically defined measurements, piece of geometry. It's a very simple project, and in doing this, to change things, you could come back here and modify the dimensions, and that would work just fine. But with parameters, by leveraging parameters, or parametric CAD as people like to say, you can create objects that are dynamic based on values that can change without having to go back and edit the original defining sketches. So to make an example here, I've got another sketch created over here, another project, and in it I have a lot of parameters set. Now to get to parameters, you're going to go to modify and change parameters. P is a shortcut that I use. That is not the standard one though. So we're going to bring up the parameters window, and you can see I've defined a lot of things already. A lot of what I've defined here are distinct values. So for example, the inner diameter of the hub, that's a fixed value based on the standard for a motor shaft. And the outer diameter of the propeller I've also statically defined. A couple other items in here as well. Now, there are also ones that are driven or calculated values. So for example, the outer diameter of the hub, I don't really care how big it is other than I know I wanted a certain thickness. So what I've done is made the outer diameter of the hub equal to the inner diameter plus 3.2 millimeters. What that'll do is 3.2 millimeters diameter, so 1.6 millimeters radially. That divides by 0.4 four times, very, very evenly. So it'll give us a 4-line or 4-wall thick hub. Similarly, for the prop inner and outer diameters, I have made the inner diameter, in other words, how thick we essentially want the placeholder walls to be. The outer diameter of the propeller less 2.4, again 1.2 millimeters radially, 3 lines. I've also defined some other things, a fillet standard radius, which is a function of the hub height and the prop height. And down here I've defined another one that you'll notice has no unit. This is the spoke, the number of spokes we want to have. Now when you're making parameters, you can choose the unit, but if you're going to be doing something that is a count, you're going to select no units when creating that, and that's how I created this one here. There's a couple other values in here as well, the spoke length and some other bits and pieces. Essentially what we should have done here is created any value that we're going to use in the sketch should be represented essentially as a variable here. So we've got all these created. Let's go ahead and get a sketch made. As usual, we're going to do that up here in Create Sketch. I'm going to choose my Z-plane. And we're going to start with some circles. So I'm using C for circle. We're going to start right here at the origin. And the first one we're going to do is going to be the hub's inner diameter. Click on it and click Enter. We're now going to do the hub's outer diameter. C again, click, hub, outer diameter, and hit Enter. We can see we've now got a 5.2 millimeter circle and an 8.4 millimeter circle. Again, defined exactly off of 5.2 and 8.4, exactly off of our parameters. So we're now going to go ahead and create the outer parts of the propeller. Again, C for circle. And this is going to be prop outer diameter. Hit Enter. I'm going to zoom way out here. C for circle again. Prop inner diameter. Hit Enter again. Now we've got something that looks an awful lot like a propeller. At this point, we need to create the spokes that are going to connect these two pieces together. Before we do that, in our geometry here, something I want to do is take this inner circle that is representative of our inner hub. I'm going to right click on it. I'm going to click Fix Unfix. What that's going to do is fix essentially this particular piece of geometry within the sketch. So if I were to take other pieces of geometry and constrain them against this, this piece will no longer move. The other pieces will move to accommodate it. This is to make sure that everything stays relative now to that hub, if you will. So in order to make our spokes, we're going to make a rectangle. And this rectangle is going to have some very, very specific dimensions to it. We can start creating it wherever we want. I'll actually create it over here. So R for rectangle. I'm going to click and drag. So the first we need to do is set the width of it. So I should have a value for that. Spoke width should already be a parameter. Hit enter. So we have a 1.2. Now I'm also going to give the length here a length of spoke length. And hit enter. Now we've got this rectangle. We want to make sure this rectangle, which I could move if we wanted to, but I want to make sure this rectangle sits tied perfectly to my circle here. So I'm going to do that with a constraint. So I'm going to move this over here just so we can see it a little more easily. And I'm going to grab two very specific things. I'm going to click first, back out. I'm going to click on the bottom line of that rectangle of the spoke. Then I'm going to hold down Shift, and I'm going to click on the very center of the circle. And when I do so, you'll see up here in constraints, a lot of them will have grayed out. One that will not have grayed out is midpoint. So I'm going to click on midpoint, and you'll see what has happened is that has now snapped directly to the center of our hub. And it does a couple of other things. When you say you want a midpoint, you're telling it two different things. You're telling it both, A, you want this line to be coincident, in other words, share a point with whatever point you're selecting, but that you also want that point to bisect the line. So that's what midpoint has done. It both centers it side to side, if you will, and makes sure that it's on the line up and down. All right. Now we want to go ahead and make this happen a few more times. We could certainly create more rectangles, but for our purposes, it's actually going to be easier to do what's called a circular pattern. So we come up here to create, and we're going to go circular pattern. Now we got a couple of things we have to select. We have to select the objects we want to pattern, and we have to select the axis about which we're going to rotate them. So in this case, we're going to say Object Select. I'm going to double click on my rectangle. This will select my entire rectangle. I'm now going to select the center point of my center point. There we go. It selected the center point for some reason as one of the objects. So to get rid of that, to clear these out, if something gets selected you don't want to, you can hit this little X. And then I'll come back and I'm just going to double click those again. Now it says correct. 4 selected. Select a center point. We can see it's already gone ahead and created a 3-spoke pattern. Now our quantity tells us how many times Fusion how many spokes it should make. In this case, we're going to use the spoke count to define how many spokes we want. So in this case, we want 3. Click OK. Go ahead and click Finish Sketch. Show our sketches over here. Now we've got something that looks an awful heck of a lot like a propeller. When we're still at this point, we could come to our parameters, and we could certainly add an additional spoke. Say we want 5 spokes. Say we want 4 spokes. Doesn't matter. In this case, I'm going to keep it at 3 spokes. And we're going to start extruding some of this into space. So I'm going to hit E for extrude. We're going to come here and we're going to select all the parts of our exterior of our hub. And we're going to use a value of hub height to extrude that. Now we're going to go ahead and extrude the rest of this. Again, E for extrude. I just have to be careful about what I select this time. I'm going to make sure I select my spokes. Then as I come out here to the edges, there's actually a little tiny bit of overlap that you can just barely see that we don't want to select. So I'm just going to select everything other than that. Again, I'm holding Shift and clicking. And now we're going to extrude that to prop height. And very, very importantly, over here on the right, we want to make sure join is selected. Click OK. Now, if we hide our sketch, we got something that looks very similar to what we had before. What we should also be able to do at this point is modify our parameters to change the outcome of what we've drawn. So if we go back to parameters and say we want to change to a different outer diameter. I want a 4-inch diameter prop. When we do this, because everything we did was parameter driven, all of our extrudes, all of our everything, we should be able to scale this however we want and have it still properly function. So we can say I want a 6-inch propeller, and we determine that maybe our prop height should be a little higher, so we change that to 4 millimeters. Now, something that will not work that's worth noting is our spoke count. If we go ahead and change our spoke count to 5, you'll notice we have a problem. We have this problem because we've now, in editing that pattern, we have changed the geometry that we referenced with our original extrude. Essentially, the 3 original spokes that were there are no longer there. They were replaced essentially by 5 new ones. So there is a way around that, and we would do it by patterning the actual bodies as opposed to patterning the geometry, but that is for another time. For our purposes now, we'll do one more thing. We'll go ahead and add fillets to everything to make it look nice. And when you're selecting everything the first time, you don't technically have to hold shift, but I do like to, since you will have to hold shift or control as you do multi-selections pretty much anywhere else when you're not doing initial selection. We should now, in our radius, be able to say we are looking for our fillet standard radius and hit enter. Oh, there was a problem. Cut join does not work. So this is likely because a piece of this particular parameter is not valid with some of the values that we have given it. Okay, so we'll give this a dummy value of 3 for the moment. We'll come back to our parameters. So it looks like I was trying to define that fillet based on the hub height less the prop height. And that probably works fine for certain heights, but not for the height that I have given it. So we're going to actually change that fillet standard to a fixed value. We'll go ahead and change that to 3 and hit OK. Now that we've done that, we can come back and edit our feature, and we can replace that fixed value with the parameter value. So now we have our propeller placeholder here that was fully created and driven by those parameters. Now, even after adding those fillets, we should still be able to modify a significant number of parameters, the major items, so we should be able to make this, for example, larger, because the geometry that we are changing there is the same, they're the same objects. We're not creating or subtracting any objects, so Fusion can keep track of which particular intersections it should perform what actions on. Alright, I hope that's been helpful. Next go around, I think we'll try to cover the actual creation of body-based patterns or whatever else you all want to hear.